The internet, it feels like it's just always been there, right? Like it's a permanent part of our world. But it wasn't some single big invention. Nope, it was built piece by piece. And it all started with just 4 computers. Over the next few minutes, we're gonna pull back the curtain on how that actually happened. I mean, think about it. You're using it right now to watch this, but how was it really built? It wasn't just one magic moment. It was this decades-long journey of smart people solving one totally impossible problem after another. And that's exactly the story we're gonna dig into today. Okay, so first things first. Before we can even get to the internet with the inter part, we've got to wrap our heads around what a single net even is. This is the absolute foundation for everything else that comes next. So at its most basic level, a network is just a bunch of connected gadgets. Computers, printers, whatever, all linked up so they can talk to each other and share stuff. Think about your office or even your home setup. That's a network. The internet? It's really just that same idea, but scaled up like a billion times. A really helpful way to picture this is to think in layers. You've got the network itself, which is all the physical stuff, the cables, the routers, the hardware. Think of it like the actual roads in a city. And then you've got a distributed system. That's the clever software running on top of those roads, directing traffic and making all those separate computers work together like they're one big machine. All right, so you've plugged in a few computers. Awesome. Now what? How do you make sure that when one computer sends a message, the other one actually understands it? You need a common language. You need a set of rules. And in the networking world, we call that set of rules a protocol. You can literally think of it as the grammar and etiquette for digital conversations. Without protocols, the internet would just be total chaos. A bunch of devices all shouting at each other in different languages. Nothing would get done. So what do these rules, these protocols, actually do? Well, they boil down to 3 main things. First up is syntax. That's the structure. Where does the address go? How is the message formatted? Then there's semantics. That's the meaning. This part makes sure that a certain bit of code means, hey, this is a picture, not this is a text file. And finally, you have timing. That's all about the rhythm of the conversation. When to send data, how fast to send it, all that good stuff. Okay, but how does one of these protocols become the protocol? How does it become the standard? Well, it happens in 2 main ways. Some become what we call de facto standards. That just means they became the standard because, well, pretty much everybody started using them. Think Microsoft Office files. Then you have de jure standards. These are the official ones, set by a formal group like the IEEE, which is the body that gives us the Wi-Fi rules we all use every day. Okay, so now that we've got the basics down, we know what a network is, we know what a protocol is, we can finally get to the main event, the incredible true story of how a tiny government project ballooned into the global internet we know today. And this timeline really lays it all out. It all kicks off in 1969 with ARPANET. But the real game changer, the big idea, hits in 1972. What if we could connect different, totally separate networks together? That single question led Vince Cerf and Bob Kahn to develop TCP/IP, which is basically the universal translator for networks. Once that became the official standard in '83, the stage was set for Tim Berners-Lee to come along and build the World Wide Web right on top of it all in 1991. And would you look at that? This was it. This was the entire internet back in 1969. Just 4 computers at 4 universities: UCLA, UCSB, Stanford Research Institute, and the University of Utah, all connected by this thing called ARPANET. It's kind of mind-blowing to think that the global system we use every single day started right here, with just these 4 dots on a map. And this is the part that you really have to get. ARPANET was just one network, but the world had lots of different networks, and they were all totally incompatible with each other. The absolute genius of TCP/IP was that it created a way for all these separate walled-off networks to finally talk to one another. It created a network of networks. It's what literally put the inter in internet. So we've got the history, we've got the rules, but let's get practical. How does an email you send, or a video you're watching, actually travel from one side of the world to the other? What's the actual highway that data is driving on? To really get this, we've got to compare 2 big ideas. First, there's circuit switching. This is like an old-school telephone call. It opens up a dedicated private line just for you. But the internet uses something different, something called packet switching. This is way more like the postal service. It chops up your message into these tiny little pieces called packets, sends each one off on its own journey, and then puts them all back together perfectly at the other end. And choosing packet switching, man, that was absolutely revolutionary. See, a dedicated circuit is super wasteful if nobody's talking. But with packet switching, millions of people can share the same data highways all at once, really efficiently. And here's the other cool part. If one road is blocked, the packets just find another way around. This is what makes the internet so incredibly tough and able to grow so big. Okay, so how do these little packets actually travel? Well, they move through one of two ways. They either use guided media, where the signal is guided along a physical thing, like a copper wire or a fiber optic cable, or they use unguided media, where the signal just travels through the air. Think Wi-Fi, your cell signal, or satellite internet. And this little chart here gives you a quick and dirty breakdown of the pros and cons. You've got your twisted pair, like an old phone line, which is super cheap but pretty slow. Coaxial cable is a bit faster. Then there's fiber optic, which is just ridiculously fast, but boy, is it expensive to lay down. And of course, wireless, which gives us amazing freedom and lets us be mobile, but that comes with its own set of security headaches. The internet you use today, it's a massive, complex mashup of all of these working together. All right, so let's just take a step back for a second. We've gone from this tiny experiment with 4 computers all the way to a global system that runs on this incredibly complex web of rules and physical cables and wireless signals. When you really look at it, the story of the internet isn't about one single eureka moment. Not at all. It's a story about slow, steady progress. It's about brilliant people solving one problem after another. How do we even connect these machines? How do we get them to speak the same language? How do we send data across the entire planet efficiently and without it getting lost, one problem at a time? And all of that brings us to one last really important question for today. You see, all those first protocols, they were designed to solve a technical problem, connecting machines. But now that we've connected pretty much the whole world, our biggest challenges aren't technical anymore. They're human. So what are the new rules, the new protocols that we need to figure out for connecting humanity